This is our second video on myths and facts in statistics. One of the most frequent reasons for rejection of research papers and PhD theses is the statement that data are not normally distributed. Therefore, parametric tests are invalid. This comment sounds statistically correct, but it reflects a misunderstanding of how normality operates in modern statistical inference. Why this rule exists? Classical statistical tests were developed under theoretical assumptions of normality. Over time, these assumptions were simplified into rigid rules that are now applied mechanically without considering sample size or robustness. Modern statistics, however, has moved far beyond such implications. A common myth is that raw data must be normally distributed for parametric tests such as t-test or ANOVA. In reality, as explained by Field and by Tabachnik and Fiddle, parametric tests do not require raw data to be normal. What matters is the distribution of residuals and, more importantly, the sampling distribution of the mean. Another widespread belief is that a significant Shapiro-Wilk test automatically invalidates parametric tests. Anti-Field clearly explains that with large samples, normality tests becomes overly sensitive and detect trivial deviations that have no practical impact on statistical inference. Thus, statistical significance in a normality test does not imply that parametric tests are inappropriate. Some reviewers assume that normality is more important than sample size. However, central limit theorem tells us that as sample size increases, the sampling distribution of the mean approaches normality regardless of the underlying population distribution. Glass, Peckham, and Sanders demonstrated as early as 1972 that ANOVA maintains correct error rates even under substantial non-normality when sample sizes are large. Extensive simulation studies have shown that ANOVA is robust to moderate deviations from normality, particularly in large and balanced samples. Serious problems arise mainly with small samples and extreme outliers. Instead of obsessing over normality tests, reviewers should focus on homogeneity of the variance, independence of observations, effect sizes, and the use of robust alternatives such as Welch ANOVA when necessary. Normality tests should be used as diagnostic tools, not as automatic rejection criteria. In large samples, failing a normality test is normal. Sound statistical judgment requires understanding robustness, not mechanically applying outdated rules. I conclude, in large samples, failing a normality test is normal. Thanks for watching. Share with the experts, let them give comments, and if there is any opposition to this, please write with free hand. Thank you.
Always share the videos of Dr. Sachdeva to your friends who are interested in data analysis.